So there's different ways in which variables can be related to one another. So far, we've been working with a single variable, one variable at a time, trying to figure out what the mean is, what the standard deviation is, and all that good stuff. Now what we want to do is figure out how two variables relate to one another, right? So we have different types of relationships, and those relationships are, or they correspond to functions that you may have explored in the past, like linear functions or quadratic functions, cubic functions, quartic, exponential, natural log. If you're having flashbacks to college algebra or trig, that's okay. If you're having nightmarish flashbacks, don't worry about that, because we don't do that much of the algebra, college algebra stuff in here that it should be striking fear into your very soul. Yeah, we do a little bit. We just we call back to some of the things that we talked about in those classes. Right? So, and like the names of things and what they look like. Not so much in terms of, like, I'm never going to ask you to factor anything. Let's just put it that way. Right. So, so yeah, if that makes you feel a little bit better, hopefully. I mean, that's the plan anyway. And in fact, as you probably discovered so far, it's pretty tech heavy in this class. Aside from the obvious thing of like you're learning through a computer, put that aside. I'm talking about like how are we evaluating statistics? Well, any class or any area of math in which the numbers are ugly, technology plays a vital role, right? Because it's just a matter of efficiency. Right? If you want to draw conclusions at a rapid rate, I mean, just think about the virus, for example. They say, oh, it's crazy. It's a miracle that we came up with the vaccine in such a short period of time. And it's like, well, compared to what? Compared to like 100 years ago? Compared to last year? I don't know. But if they're comparing it to the last time there was a pandemic, then, well, yeah, well, we better. Technology is advanced. The ability to conduct research clinical trials rapidly has improved greatly, and so it better be the case that we can do stuff like that more efficiently. So I'm not saying that Desmos is the answer to those really pressing questions, but you know, it doesn't hurt when you start thinking along those lines. All right, so scatter plot is when we actually just looked at the scatter plot when we talked about normal probability plot. It's when you plot two variables against each other, right? And it creates an ordered pair. That ordered pair gets plotted as a point, right? And those points form either a pattern or they don't. If they don't form a pattern, we say that there is no correlation between the variables. If they do form a pattern, then it's probably going to be one of these patterns. And if it's not, then it's probably a more advanced type of function that's beyond the purview of this class, but you may still be interested in it, in which case we can talk, but it would not be the focus of the material that we're covering in this class. Right? So the way we determine whether variables are related, we take a look at the scatter plot, and we also determine what's known as a correlation coefficient. Oops, that's the wrong one. All right. So we want to talk about, specifically when we're talking about a linear relationship, we want to talk about whether or not there's a trend to the data and whether or not there are any points that deviate meaningfully from those data points, from the overall trend of the data. We call those striking deviations from the pattern, right? Any striking deviations could be considered an outlier, right? And an outlier, in its most basic sense, is a term that defines itself because, you know, it lies outside of the overall trend of the data, right? So when you look at a data set and you see, you know, I'll just do a rough sketch here. You got point, goose, you know. Pretty safe bet that this is going to be an outlier. This point over here. All right. So it doesn't take much in order to make a determination, or at least an initial claim, that a point lying off the beaten path would most likely be an outlier. All right. In many ways, that's really all there is to it, because once you identify an outlier, the next step in the process is to try to figure out what to do with that outlier. Do we get rid of it, as in it shouldn't be there? Or do we focus on it, as in, ooh, I didn't see that coming? You know, like those, let's just put it this way. Like when you get the vaccine and they make you sit in a room for 15 to 30 minutes, they're trying to make sure you're not one of those outliers. You know, like those allergic reactions. Yeah, well, if you're going to have an allergic reaction, it's going to happen in the first 10 to 15 minutes or so. Like, oh, how nice. So the next 10 to 15 minutes will be the most stressful of my life. Got it. All right, great. Thanks. That's really heartening. But they're trying to make sure that you're not one of those outliers, because it happens, but it doesn't happen often enough that it would be a deal breaker for the vaccine. So it's something, okay, we didn't see that coming. We'll keep an eye on it, but we can't just dismiss it. So it's like you come up with a vaccine, and it turns out that in 0.1% of the population, a person's head is going to explode, like literally explode. I'm trying to be like hyperbolic here, so I don't make it too real. Like their head is literally going to explode. So do you say, well, it's only 0.1%? Like, that's hardly anyone. You know, well, 0.1% of what? What's the size of the population? That could be a lot of people. You know, you don't just dismiss it. You report it and you say, not likely, but keep an eye on this. Right? This is a possibility. Right? As opposed to maybe an error in data collection. You know, like you're surveying a population, and you know, like maybe elementary school students, and one student is age 5 and the other student is age 9. And when you were putting it in a spreadsheet, you forgot to hit enter after the 5. So you accidentally typed in 59. All right. So that's an outlier. But you can't just say, oh, yeah, there's a 59-year-old student there. No, you would say that was an error, right? That one would go, or a correction would be made, right? So in most cases, when it comes to outliers, it's just something you keep an eye on. But if you want to make a real analysis of the overall data set, you would generally disregard the outlier in the computation of correlation coefficients and also trend lines. All right, so that's what we're going to focus on now. You can see these nasty, but look at that formula. R equals nightmare. All right, and then you can see below that linear regression. All these notes: slope equals A equals nightmare, y-intercept equals B equals nightmare, and then some graphing calculator stuff. All interesting, I suppose. If you have a graphing calculator, we're not going to do any of that. What we will need to know is the R-squared values, the coefficient of determination. That's really important when it comes to determining the strength of the relationship between variables. So a lot of this stuff is either related to how you would determine correlation coefficients and coefficient of determination by hand, which we're not going to do. I used to make my my stat students do that. Only because that's how I learned it. And I was like, oh, yeah, well, we might as well. And then I was like, even I don't like doing this. So I tossed it. And I also have the idea that, like, well, you can't really appreciate a formula and how it works in a calculator unless you tried it at least once by hand. And you know what I came to understand over the years? I can appreciate a formula just fine without ever using it by hand. And so this is one of those. Look at that beast. Oof. So what you need to get from this is that we're going to compute R values and R squared values, R squared being the more important. The closer the R squared value is to 1, the closer the relationship is to perfection. All right. The closer it is to 0, the closer it is to the opposite of perfection. Yeah, the closer it is to no significant relationship between variables. All right. That's it. Without knowing what this R squared value is, it's like, okay, well, you're not really telling us anything, dude. I recognize that. I'm going to in